Hey Swarmers, thanks for joining us back in the Hive. We hope you're kicking sustainability lifestyle goals. Today we're diving into a topic that's super important for our planet, single-use drink containers. You know, those plastic water bottles, soda cans and coffee cups we use once and toss away. These containers might seem convenient, but their impact on the environment is anything but. There is loads to consider, so we're going to break it down. From the raw materials needed to make them, to how they're manufactured, transported, and finally disposed of. We'll also compare plastic to aluminium and talk about recycling. Oh, yeah, I'm Australian, so I say aluminium, but it is the same thing as aluminum. There's a lot to consider in this space, so we'll have 3 further videos looking at single-use coffee cups, one delving into the containers for carbonated drinks because they're a bit different, and one exploring those waxy cardboardy containers like milk. First off, let's talk about where it all begins, the raw materials. Plastic drink containers are made from petroleum, a non-renewable resource. Extracting petroleum involves drilling, which can lead to massive oil spills and enormous habitat destruction. Not to mention, it's a major source of carbon emissions. Did you know that it takes about 17 million barrels of oil annually to meet the demand for bottled water in the US alone? That's enough to fuel 1.3 million cars for a year. Aluminium, on the other hand, is made from bauxite ore. While aluminium is abundant, extracting it is no picnic. Mining bauxite is energy intensive and can lead to deforestation, soil erosion, and water pollution. Plus, processing bauxite into aluminium requires a lot of electricity, primarily from fossil fuels. In fact, producing a single tonne of aluminium generates about 12 tonnes of CO2 emissions. Next, let's look at the manufacturing process. This obviously varies significantly between plastic and aluminium, and again, we'll start with plastic. Turning petroleum into plastic bottles involves several energy-intensive steps, including refining, polymerization, and molding. This entire process emits greenhouse gases and other pollutions. The energy consumption for producing plastic bottles is quite staggering, 2,000 times more than producing tap water. Manufacturing aluminium cans is also energy heavy. The process of smelting aluminium from bauxite ore is one of the most energy intensive industrial processes there is. However, one major advantage of aluminium over plastic is that it is infinitely recyclable, but we'll get to that in a bit. Now, let's talk about how these containers get from the factories to you. Both plastic bottles and aluminium cans need to be transported, often over very long distances. This involves trucks, ships, and trains, all of which burn fossil fuels and emit carbon emissions. Ocean freight is the most commonly used method for shipping large quantities of goods over long distances. Containers are transported on massive cargo ships. So how efficient is ocean freight? Well, it's actually the most energy efficient mode of transportation for long distance shipping. Cargo ships produce about 10 to 40 grams of CO2 per tonne kilometre. That's pretty low compared to other methods. But remember, the shipping industry still contributes about 3% of global CO2 emissions because of the huge volumes of goods transported this way. Besides CO2, cargo ships also emit sulfur oxides and nitrogen oxides, both of which pollute the air and water. However, it's generally the most cost-effective and high-capacity option for bulk shipments. The main downside? It's very slow, so forward planning is required. Let's talk about rail. Rail transport for freight has significant environmental advantages compared to other modes of transportation, like trucks or, of course, airplanes. It is more energy efficient, producing lower greenhouse gas emissions per tonne kilometre of freight. Trains can carry larger volumes of goods with less fuel consumption, reducing the carbon footprint. Additionally, railways contribute to less road congestion and wear, which helps minimise the pollution from road transportation. However, the environmental impact of rail transport depends on factors such as the energy used for locomotion, diesel versus electric, and the infrastructure maintenance. To calculate the average range for CO2 emissions per tonne kilometre, we can use some widely accepted benchmarks. Electric rail will produce between 6 and 22 grams of CO2 per tonne kilometre, depending on the source of electricity, renewable energy versus fossil fuels, while diesel rail produces between 14 to 30 grams of CO2 per tonne kilometre. These ranges depend on the efficiency of the locomotives, the load factor, and the type of energy used. But as a rule, electric trains powered by renewable energy sources produce the lowest emissions, while diesel trains have a higher impact. And finally, road freight. This involves transporting goods by trucks. It's typically used for short to medium distances. Trucks emit about 60 to 150 grams of CO2 per tonne kilometre. The exact amount depends on the type of truck and fuel used. So it's less efficient than ocean freight and sometimes can be less efficient than rail. Road transport contributes to air pollution through emissions of CO2, nitrogen oxides, and particulate matter. But road freight is highly flexible, allowing door-to-door delivery and access to locations not served by ships or trains. It's the obvious choice for short distances and can be more time efficient for medium distances. And thankfully, we're seeing a huge influx of electric road vehicles, particularly for last mile delivery. However, the capacity is limited by the size and the number of these trucks. So, the sodas you grab from the convenience store fridge will most likely get there using ocean freight, the most environmentally responsible method, followed by a combination of road and/or rail. And both are an area of constant improvement in regards to environmental impact. Now, what happens after you take that last sip? Because it's only the story of the liquid which ends there. Most plastic bottles end up in landfills, or by accident, in the ocean. In fact, only about 9% of all plastic ever produced has been recycled. The rest takes hundreds of years to break down, leaching harmful chemicals into the environment all the while. Our oceans are drowning in plastic, with about 8 million tonnes entering the ocean each year. This plastic pollution is devastating for marine life, and microplastics have now entered our food chain. Aluminium cans have a much better recycling rate of about 50%. Recycling aluminium is significantly less energy intensive than producing new aluminium from bauxite. In fact, recycling aluminium saves 95% of the energy required to make new aluminium. However, despite these benefits, many aluminium cans still end up in landfills. 50% recycling rate is not good enough. Let's go a bit deeper. Plastic recycling is tricky. There are different types of plastics and not all are recyclable. Even when they are, the plastic recycling process degrades the quality, meaning plastic can typically only be recycled a few times before it's no longer usable. Plus, the recycling process itself is energy intensive and not always economically viable. Aluminium, on the other hand, can be recycled indefinitely without losing quality. This makes aluminium a far better option if you have to choose between the two materials. Recycling aluminium not only saves energy, but also reduces the need for mining new bauxite, mitigating some of those terrible environmental impacts. So, what's the takeaway here? Single-use drink containers, whether plastic or aluminium, have significant environmental impacts at every stage of their life cycle, from raw material extraction to disposal. While aluminium is better in terms of recyclability, both materials contribute to pollution and carbon emissions. So what's the best solution then? Switching to reusable drink containers. Invest in a good quality, double insulated stainless steel water bottle. Use a reusable coffee cup for your caffeine intake and consider a carbonating machine for those who love bubbles in your drinks. Every time you choose reusable over single use, you're making a positive impact on the planet. Stay tuned for the next installment in this series on containers for carbonated drinks. Make sure you're subscribed so you don't miss it. The power to make a difference is in your hands. Thanks for being awesome swarmers. We know that you're doing your bit and we love you for it. Stay happy, stay healthy, and stay sustainable.